what we're going to do here is we're going to go over the conditional probability problem, or example problem. And here's what we have. I'm looking at page 198 and number 34. And we have the U.S. Department of Transportation reported that during November, 83.4% of the Southwest airline flights were on time, 75% of U.S. Airways, and 70% of JetBlue, or 70.1% of JetBlue, were on time. And it's for all the flights. So it's fully inclusive here. And 40% of the arrivals at Concourse A are Southwest airline flights, 35% are U.S. Airways flight, and 25% are JetBlue flights. Getting late. And what we're going to do is first develop a joint probability table with the 3 rows, airlines, and 2 columns on time arrivals versus late arrivals. Let's go for this. What I'm going to do is I'm going to let O equal or denote that a flight arrives on time. And so what I'm going to do here is I'm going to go, the complementary of O is the flight is late. And then I'm going to let S denote Southwest. I'm going to let U denote US Air. And then finally JetBlue is going to be J. And one of the formulas you would need to be given here to get you going is that the probability of A given B is equal to, hopefully you can see that, the probability of the intersection of A and B divided by the probability of B. That's kind of how I remember. I just pull that down below. So we know that, and we're going to, like I said, we've got this nomenclature going on here. We know that the probability that you're going to be on time, given that you're Southwest, is going to be equal to 0.834. That was a given. We also know that the probability of on time given United is equal to 0.751. And then finally, we know that the probability of on time and JetBlue is equal to 0.701. Those were givens in the problem up in here. The other thing we know, as we're working with this specific formula from the introduction, or from the tee-up of the question itself, we know that the probability of Southwest is equal to 0.4. We know that the probability of United is equal to 0.35, correct? And again, this is all just part of these. I'm still working on the givens within this problem. And the probability of JetBlue is equal to 25%. Or it's really more of a proportion, of course. So here's what we're going to do first is let's pick off Southwest And I'm just going to work with this formula up here. And I know that the probability of the intersection of on time and Southwest is, I'm reconfiguring this formula up here, is going to be equal to the probability that you are on time, given that it's Southwest, given that you have Southwest, times the probability of Southwest. And then I just plug in those numbers. We already know what the probability of on time given Southwest is 0.834. And we also know that the probability of Southwest in general is going to be 0.4. And so you multiply those out, and the intersection of on time and Southwest is 0.3336 if you ran that out. And the Venn diagram, going back to your Venn diagram, it would look like this: is you would have on time and Southwest, so O and S, and then this area right in here would just be this intersection area here. And now what we can do is we can do that same exercise for the other, and the whole purpose of this is to develop a crosstab table for the joint probability table. So we also know that the probability, I'm just going to run this out for United and also JetBlue. We know that the probability for O and the intersection of United is equal to the probability of United, or probability of on time and United, times the probability of United. I'm going to run that out, and we come up here and get the probability of on time and United is 0.751. I'll multiply that times the probability that you're United, 0.35, and you'll get a value. If you ran that out, it would be equal to 0.2629. The final piece of the puzzle in order to build the joint probability table is we have to get the probability of on time and the intersection of JetBlue, which is the probability of on time given that you're JetBlue, you have a JetBlue flight, times the overall probability of JetBlue. Okay, so it's the probability of on time and JetBlue is equal to the probability of on time given that you're JetBlue times the probability of JetBlue. And if you run those numbers out, this is plug and chug, it's going to be 0.701. That from up here, And we also know that the overall probability is 25%, so 0.25. And if you ran that out, you're going to get right at, you get exactly 0.1753. So what do we know? We now know a lot about what's going on inside this specific airport up in, where are we at? We're up in Rochester or someplace? Yeah, Rochester International Airport, and we're in Concourse A. So we know a lot about what's going on up here, very specific to Southwest US Air and JetBlue. Another page here. So from this, I can create that joint probability table. And the joint probability table is fairly straightforward. You would have Southwest, you would have US Air, and then JetBlue, because those are the three airlines that we're concerning ourselves with. There's a on time, there's a late, and as you may recall, that was the complementary of O, and then a total. And the key here is this everything over here, everything has to come down and equal 1, both across and down. So now, what is, and so all we have to do is fill in this table. And we know that the intersection of southwest and on time was 0.3336. We know that US Air, the intersection, was 0.2629. And then JetBlue, we calculated, was 0.1753. Hopefully this is making sense so far. And this is all going to come together. Oh, the other thing we know, by the way, is we can fill in 0.4, because we know that the total flights of Southwest were 0.4. The total flights of US Air is, what is that? 0.35, yeah, 0.35. And then we know that the total flights for JetBlue is 0.25. So far, if you take 0.4, 0.35, and 0.25 added up, you get 1. So we're golden. Okay. Now, the way you fill this part in is you go 0.4 minus 0.336. And if you ran that out, you're going to get 0.0664. So to fill that in, I just keep working this table back and forth. I know that this is 0.35 for the total, and on time, the intersection of on time and US Air is 0.2629, and so now I know that the intersection of US Air and late is going to be 0.0871, because these just have to add up. And then the final part of this, the meat of the table, is a 0.25 minus 0.1753, which is 0.0747. And so I just total these up. And if you totaled these three numbers together, you would get 0.7718. And you would get late was 0.2282. And once again, adding across to get 1.0. Now that you have this table all set up, you can pretty much go anywhere you want as far as manipulating the numbers or understanding the numbers and what's going on inside this concourse. So the next question is, you've developed the joint probability table, and B is an announcement has just been made that a flight has arrived at gate 20 at concourse A. What is the most likely airline for this arrival? And if you think about that, which one is going to have the on time? And more specifically, it's not even asking for on time, it's just saying it's just arriving. And clearly 40%, so it'd be Southwest. So the answer to B would be Southwest Air, because they represent 40% of the flights. You knew that from the given, so you could have answered that question without even running the table. So now, what's the probability that the flight will arrive on time? This is what you didn't know until you actually created the table. And you know it from here that it's so C is 0.7718, or about 77%. And that would be the answer to C. And then finally, they have an announcement be arriving. Oh, here we go. The last one is, suppose the announcement is made that the flight will be arriving late. What is the most likely airline that is that's going to show up there? And what would you surmise that is going to be? And you can just look at it. Whichever is most likely to be late, it would be US Air. You could do some more calculations, but just And you just kind of know that it's going to be 0.0871, which is going to be, so it's going to be US Air. And the least likely to be on time, who would that be? Be Southwest, because you've got a 7%, 8 or 7.5, 8.7, and 0.0664. And so you know the numbers there as well. So the key to this process is creating this table, understanding that this is the intersection. Okay, these are the intersections of Southwest and on time, US Air and on time, and then everything needs to add up to 1. That concludes this discussion on discrete probability, or rather conditional probability.